Hey, so in this video we're going to discuss 3 strategies for solving advanced equations, and we have it organized by we're going to solve 4 equations using the first strategy, and then we'll switch to a different strategy. So the first strategy is to rewrite the equation, and by rewrite it depends on the type of equation what we mean by that, but basically it's essentially can you write it in a different way that's going to make it easier to solve. So for the first example, we have 4 times x plus 3, and we could rewrite that by, it's written as a product, so we could rewrite it as a sum by distributing the 4. So then we could have 4x plus 12 equals 20. And then it's a pretty simple equation, so then you could solve it by flipping the 12 to the other side, and you get 4x equals 8, so x equals 2. The next example is a quadratic. So to rewrite this would mean to actually square the x minus 7 by writing it out as a sum instead of a product. So we could use a generic rectangle to multiply x minus 7 times x minus 7. And then we would have x squared, a negative 7x, another negative 7x, and a positive 49. So if we combine the like terms, we would have the expansion x squared minus 14x plus 49 equals 9. And now it's expanded into a trinomial. So that's sort of our strategy of rewriting this. So then we're used to solving quadratics that look like this, but we like to have it equal to 0 so that we can either factor or do the quadratic formula. So if I bring this 9 over here, then it would be plus 40 and equal to 0. Which, if it would factor, there would be numbers that multiplied to 40 and added to negative 14, which is negative 4 and negative 10. So then we have factor x minus 4 and another factor x minus 10 equals 0. And then use the 0 product property, or what I like to call the ZPP. So if x minus 4 equals 0 and x minus 10 equals 0, then x equals 4 and x equals 10. So there are 2 solutions to that quadratic equation. The third one, rewriting this, if you think about rewriting it as in you're going to expand or multiply, that doesn't really work for this one because there's not really anything to expand. But you might notice that the numbers are pretty big, and each of these terms has a common factor of 100. So rewriting could also mean, just like you can multiply an entire equation to scale it up, you could also, if you divide every single term by the same number, that's a valid move when solving. So then this equation just became 3x minus 2 equals 10, which will solve the same way. Flip the 2, the negative 2, and then x equals 4. But it's a little bit quicker to solve it if you can reduce the numbers and make them smaller. And for our final example of rewriting, we have a rational equation, or something that we could use fraction busters to solve. And we just did this, so we want to think through what we could multiply the entire equation by so that we could cancel out a factor of 6 and x in the denominator. So we're going to multiply the whole thing through by 6x over 1. So essentially, it's pretty easy to see why this is going to be a rewriting. At this point, the equation has fractions in it, but pretty soon we're going to get rid of the fractions, and that's our rewriting strategy. So 6x times 1 is 6x minus And that would be 30x over 6x equals 6x squared over 6. Canceling and reducing each term then gives us 6x minus 5 equals x squared, which is another quadratic. So we can try to factor it by rearranging it all. So x squared, I'm going to take the 6x over here and make it negative, and take the negative 5 over and make it positive. What multiplies to 5 and adds up to negative 6? Negative 5 and negative 1. So the factored version would be x minus 1, x minus 5 equals 0. My work's getting kind of sloppy. And then the two answers for x would be x equals 1 and x equals 5. So that's what we mean by rewriting. And you might notice that in the second section here, looking inside, what's blub? The very first one we're going to do is the exact same equation that we did before. So here we go. What is blub? What even is blub? Blub is just a silly word that I like to use to mean something. So here's the logic behind this. This x minus 3 is grouped together. So when you look inside, you identify like a contained group that you could think of as one thing. So if I cover this up and think of this as blub. No, 4 times blub is 20. That's kind of what this equation is really telling us. So 4 times what is 20? So if 4 times blub is 20, what's blub? Blub would be 5. So this is a pretty silly example, but 4 times 5 is 20. So if we're calling what's in there blub, and what is in there has to be 5, then we've just made a simpler equation that x plus 3 has to be equal to 5. So that 4 times 5 will equal 20. Then we want to know what x is. So we can flip over the 3 and x would equal 2. Let's give it another shot on the second example. So here, x minus 7 squared equals 9. And our x minus 7 is what we can cover up and think of as blub. So blub squared is 9. So what does blub have to be? 3. Or negative 3. Because when you square a positive or square a negative, the answer still comes out positive. So here, let's write it out. Blub could be 3 or negative 3. So then, according to this logic, we kind of have two different results here. The x minus 7 could equal a 3, or the x minus 7 could equal a negative 3. And we can solve both of those mini little equations. So in this one, when we flip over a negative 7, we'd have x equals 10. And here, when we flip over a negative 7, it would be negative 3 plus 7, so x equals 4. Which, whoa, it's the same answers as these. Okay. These bars are called absolute value bars. And what they do is they always make the answer to what's inside of them positive, because absolute value means how far away is it from 0. So it's a distance. So essentially this is going to be our blub, what's inside there. Because remember the strategy is called looking inside. So we're looking inside and thinking, okay, the absolute value of blub is 9, so what's blub? Well, it could be 9, or it could have been negative 9. So again, blub could be 9 or negative 9, because absolute value makes the answer positive. So it could have been a negative 9, and then the absolute value turned it into a positive 9. So another way of writing that it could be 9 or negative 9 is to write that x minus 7 is equal to plus or minus 9, meaning it's equal to a positive 9 or a negative 9, and this is just like a shortcut way of writing 9 and / or negative 9. So then we can still solve this equation for x by flipping this over as a positive 7. So then we have x equals 7 plus or minus 9, which is just shorthand for 7 plus 9 and 7 minus 9. So 7 plus 9 is 16, and 7 minus 9 is negative 2. So our two answers for x here would be 16 or negative 2. And the last one for looking inside is the square root of 2x minus 1. So inside, this time is really looking underneath of there, because anything that's underneath a square root has imaginary or implied parentheses around it. So the square root of blub equals 3. So we're taking the square root of blub and getting 3, which means that blub had to equal 9, so that the square root of it would be 3. So our blub was 2x minus 1, so 2x minus 1 was equal to 9. And then we can continue to solve that simple little equation for x. So 2x equals 10, so x equals 5. All right, and we're about to go over the third strategy, which is undoing. So to think about this, we need to think about the variable. Think about it this way. If we knew what x was, we would add 3 to x, and then we would multiply by 4, and it would equal 20. We would add 3, then multiply by 4, and we would get 20. So if we want to solve for x, we want to do the opposite thing. We want to work backwards. And it's kind of like there's layers on what happens to x. First you add 3, then you multiply by 4. And so if we peel back the layers like an onion, then we would first have to divide by 4. Because the last thing that happened is the first thing that has to unhappen. So dividing by 4 cancels that 4 out. And you have x plus 3 equals 5, so x equals 2. So just want to draw your attention to one thing real quick. That equation we have now solved 3 times. So this strategy was undoing, which began by dividing by 4. The strategy looking inside began by covering this up and thinking 4 times blub had to equal 20. And then the top strategy was to rewrite it by distributing the 4 inside. But obviously we still got the answer x equals 2 each time. So that's good. And for that equation, any of those strategies would work equally well. Same for this one. Although for this equation, you're going to notice that some of the strategies took a lot longer than others. So to undo this, again, think of what would happen to x. If we knew x, we would subtract 7, and then we would square it, and we would get 9. So the first thing we need to undo is the square. We need to unsquare, which the opposite of a squaring operation is to take the square root. So we're going to take the square root of both sides of the equation, and then the square root and the square cancel out, and because they're inverse operations, and we have x minus 7 equals the square root of 9. But since we're solving an equation, we know the square root of 9 could have been the positive or the negative square root of 9, so we're going to use that plus minus symbol again, meaning negative 3 times negative 3 also equals 9, as well as positive 3 times positive 3. So there's our potential for having two answers, which makes sense because this is a quadratic equation. And then we can flip the 7, so we have x equals 7 plus or minus 3, which gives us the two answers, 7 plus 3 of 10, and 7 minus 3 of 4. So that's also the third time we've done that equation. So here we have done it by undoing the square. Right above we did it by looking inside, but we still had identified that it could be a 3 or a negative 3, which gave us that same 10 and the same 4. And then up here, we rewrote it. We did the rewriting strategy, and then we had to square and factor. So again, all were perfectly valid ways of thinking about solving this equation, but I think you can kind of tell that this way was a little bit of the long road in that case. But that's okay. So we have two more. So this one is an absolute value, and if we were thinking about what we would do to x, if we knew x, we would do plus 1, then take the absolute value, then we would multiply by 2, and then we would subtract 3, and we would get 5. So again, we got to peel the outermost layer away to work backwards. So the first thing we're going to do is get rid of the minus 3 by adding 3 to the other side. So then we have 2 absolute value of x plus 1 equals 8. Then we want to isolate the absolute value. We want to move this 2, so we're going to divide by 2 so that the multiplication of 2 cancels, and then we have absolute value of x plus 1 equals 4. And then we might have to switch back to looking inside in order to solve this one. And that's okay. Sometimes you're going to move between the strategies within one equation. So I know if the absolute value of something is 4, then the blub, the something, could be 4 or negative 4. So I'm going to take the bars away, but then change this to a plus or minus 4 on the other side. And then x equals negative 1 plus or minus 4. Because I'm taking the plus 1 and flipping it over. So negative 1 plus 4 is 3, and negative 1 minus 4 is negative 5. So we have two answers again. So we had two answers for the absolute value equations, and we also have the potential for two answers whenever we have a quadratic equation. Okay, and the very last one here is a square root, and we've solved it before. We solved it by looking inside, but the outermost layer here that we would want to undo first is the square root. So to cancel out a square root, you need to do the opposite operation of taking the square root, which is to square. So we're going to square both sides of the equation, and that squaring is going to cancel out sort of the square root and just give us the 2x minus 1. And then 3 squared equals 9. And then we're going to add 1. You get 2x equals 10. We're going to divide by 2, so x equals 5. So again, in summary, these are just 3 general strategies, and knowing them is important, but it's also important to be able to choose the right one. So as you work through the basic skills, we're going to be asking you to think about how you're solving them and sort of focus on trying to choose the most appropriate method that will achieve success. So, thanks for watching. Make sure to ask your teacher if you have questions in class tomorrow.